Okay, hello everyone. Welcome to the WIZE family webinar. I'm Greg, and with me is Eric and Marc. Today we'll have a 20-minute webinar with some room for questions and answers at the end. Please post your questions into the chat window at the end. Can everyone hear me? Just to make sure that you can. Yeah, okay, brilliant. And we're going to be recording the webinar as well so that we can play it later. If you miss anything, you can always play it back. Okay, so I'll be talking about the Wize Alliance, the benefits of 169 megahertz, and what Radiocrafts can offer. And Eric and Marc will be talking about the WIZE gateways and network access, and also the end products for the WIZE protocol as well. So first of all, what is WIZE? Well, it's LPWAN, which is low power wide area network, and it's typically used for things like smart metering, smart cities, and industrial IoT. And it came into fruition from the Wize Alliance, which was founded by GRDF, Suez, and Sage MCOM, and now it has over 40 members. The Wize Alliance is the group that specifies the protocol itself, and it's based on wireless MBus, and it came out of France. And wireless MBus is typically used for smart waters and smart gas meters. And GRDF did a lot of testing with different radio frequency bands to deliver the best possible product. So these are the results of the test, where they did extensive testing with the various frequencies and found that with WIZE, with 169 megahertz, you don't need any repeaters, and therefore you can get a lot of meters per gateway without having anything in between. And then when it was actually in the field, the success rates were much, much higher than for other bands because of the longer range and the high penetration of having a low frequency rate. So here you can see that the stability of 169 megahertz was much, much higher, being at 96, 97% of every meter being read every single day, compared to some much poorer results for other higher frequency bands. So the WIZE protocol offers a very robust communication system with a very wide area of coverage. It has very secure transfer of data because it uses AES 128 in counter mode, and it's very low battery, very low power, which means that you can get a lot of usage out of it on just batteries, which is really good. It's on a proven solution, being wireless MBus, and it also has over-the-air downloads, which is really useful in today's security conscious setting where bugs happen in the field, and it's really useful to have the ability to update your firmware. The main features are 169 megahertz, which is just fantastic for range and penetration. It's a low data rate, but it means that you're transferring more energy per bit, which means that you have a longer range, and it's fairly high power as well. And this is an example of just how strong the WIZE protocol is. There was a petrol tank, which was buried 1 meter underground, and even though it was that far underground, it still had a range around it of over 200 meters, which is really impressive, and you couldn't get anywhere near that with higher frequency rates. So the difference between WIZE and MBus is that it has a new encryption method and authentication method, and it also has generic application layers for water and gas meters and for other types of systems as well later on. It has two-way communication, so you can send from the meters to the gateways and from the gateways back to the meters as well, very easily. And it has a ping pong system, which allows the meters to find the closest gateway to it automatically, rather than having to set things up in the field beforehand. And it also has over-the-air download, which can be done as a broadcast as well. It's in the 169 megahertz band, which is possible to use in the EU and outside as well, except for Russia, Ukraine, and Belarus. A lot of countries have the 169 megahertz as free to use, effectively. Wize has no licensing fee. It has no IP fee, like Sigfox or LoRa, which are other protocols that are in use as well. Wize is narrower band, which means that you get better sensitivity, and it has a better data rate than Sigfox and LoRa. It has a better range and penetration than both Sigfox and LoRa, and it also provides over-the-air download, which you just couldn't do with Sigfox and LoRa because of the data rate being so low. It would take months to do a complete download of a firmware. And this is what Radiocrafts offers. We have the 1701 high power and the 1702 high power modules for Wize. The 1702 is for application-specific development if you wanted to contact us directly and get something different from the base module. The Wize protocol has UART to communicate. It's very easy to use. It's very easy to do the encryption and authentication for the system, and it's very configurable. And it's a fairly small module as well. And as I mentioned earlier, it's fairly low power, with it having good sleep modes and things like that. So this is extra things that we can do, as well as things that we have in there already. So we can have NFC interfaces for local communication. We can have pulses or SPI interfaces for metrology, and we can have epochs in there as well for keeping time. And if you want to get started on this, you could buy a development kit from us, where we have got a nice picture there, which comes with antennas and USB cables and power supplies, so you can start testing right away the solution. Okay, it's now on to our next guest, Eric from Suez.
Okay, thank you, Greg. Good morning, everybody. My name is Eric Farnier. I work with Suez Smart Solution within Suez Group. And okay, I will try to present to you the gateways we are using and respect the time slot. Next slide. Okay, just a very short one, just to explain what we are speaking here. The gateway is the bridge between the LAN network and the WAN network, making the bridge between the device and the end system. Next. Okay, what we are calling a gateway here is carrier grade concentrators. Those have been designed for the RDF and Suez rollouts in France. Those gateways are installed on the rooftops of buildings. They are manufactured today by two companies, Sagemcom and Kerlink, that you see here. They are made upon an industrial design being very modular. One of the very important element is the one you see on the center is the SDR modem. The SDR modem is the radio element that make the link with the 169 MHz network. It has the ability to manage the 6 channel independently, and we have the capability to install 4 of them inside or connected to the concentrator, giving the ability to install 1 at each corner of the building to increase the coverage. Okay, so this SDR modem is an independent module that can be used together with the concentrator or could be used with other elements. Next. Suez network today is spread a little bit over the world. We have been talking before about the European coverage of the 169 MHz bandwidth, but you see here that we are using it even a little bit further from Europe today, as we are having pilots down in Australia and deployment in Macau and Hong Kong running on, and also in Singapore. 4.5 million devices connected today, and that means not only on Suez itself network, but also for other companies. Meaning Suez Smart Solution, the entity in which I work, is not only dealing with Suez Group, but can be also working with other entities. Next. Network access, how could we connect to the network? Today, Suez offers several ways of working. As I just said, we're not just dealing with the Suez Group, but also deal with other companies. Mainly, there are 3 ways of connecting to the network. Either there is a Suez Smart Solution network existing, and you can connect your device to it, or we need to have an extension of the coverage. And this is possible by having additional gateways installed by Suez Smart Solution, or you can buy your own gateways and deploy your own privately owned network. Next. Beside the Suez network, and as Greg mentioned before, of course, there is the rollout of GRDF in France, which will be ending by 2023. The global network will be covering 11 million gas meters with 12,000 gateways, covering roughly the French territory. I think today they are down to a little bit more than 5 million devices already installed. And they have set up a subsidiary that is called IO with Me, which will offer the connectivity to third parties. Next. Okay. So just before I stop, I just wanted to mention that we also have a webinar that will be organized by the Wize Alliance in June. I do not have the date right here, but you could see it on the Wize Alliance website. One second. Yeah, it's on June 16th in the morning, French time. I'm through. Thank you, Greg. Marc?
Yeah. Can you hear me?
Yep, we can hear you.
Yeah. Cool. Thanks, Eric. Thanks, Greg. Thanks also to Radiocrafts to invite me to do this short pitch about what we do in AllWize, specifically in terms of WIZE and about the Radiocrafts technology. First of all, I hope that everyone here is safe and all your families and so in these difficult situations. AllWize is a startup built in 2018 in Barcelona. We are based in Barcelona. Essentially, what we are trying to do is create end-to-end solutions based in WIZE technology, specifically for urban uses, which means for urban services like water, lighting, waste management, this kind of things, usually called as smart city solutions. And but we also have an interesting line of products for developing solutions in WIZE, development kits based on Radiocrafts RC1701 WIZE, which is one of the modules that Greg was mentioning before. And that's the thing that I'm going to present you today. Greg, please, next slide. So we have a couple of words for doing so. What we have made is essentially coming from the technology from Radiocraft. We create the boards and the firmware necessary to adapt the API for that modules to Arduino, which makes super simple now to create solutions connected to WIZE for everyone that knows how Arduino works, which is also super simple. If you don't know it already, the learning curve for Arduino products is also super short. So I invite you to start playing with these Arduino boards. The first product we have is the AllWize K1. It's an Arduino Uno format board. Well, usually in terms of Arduino, this is called Arduino Shield, which means that it's a board that has not a microprocessor itself, but can be mounted on top of an Arduino board with a microprocessor, and this board will control properly the Radiocrafts module in the AllWize K1 board. The board essentially have the radio module, an SMA antenna. Also, you have a micro FL antenna, also connector for connecting a pigtail, and then has a temperature sensor embedded just in case you want to start playing from this board and getting real data and transmitting something real over the WIZE connection. And also using this board, well, we have also three connectors for group sensors. Group sensors are a set of sensors, incredible amount of different sensors that you can find in the Seed Studio website. It's a very common website for makers and for the Arduino world, and they have an incredible amount of sensors that you can connect here to this board. Also, to have some sensors connected to your device, and with this board also connected to other boards with other connectivities, you can easily implement the gateway functionality only with this board. Next, correct. Then secondly, we have the AllWize K2. The AllWize K2, it's also a connected device in itself because it has the microprocessor included. It's based on Admiral MD21 low power MCU, which is a Cortex M0, an ARM Cortex M0 architecture. And it's also fully compatible with Arduino, so you can program directly with Arduino. It has the form factor from another typical form factor from the Arduino world, which is the MKR. It's a form factor where you can find also several other shields and boards that you can plug to the AllWize K2. And as I mentioned, the board includes the microprocessor and the programming interface over USB, and you can also power it with external battery. Next, Greg. So this is something you can find also in our website, in the development kits site. Here you can see also the AllWize G1 and I1, which are gateways where we mainly have implemented the K1 together with a Wi-Fi Arduino board based on Espressif microcontrollers. So with this very simple mounting, you can have very cheap and simple gateways using, of course, using only one channel, one baud rate, but you can easily create a gateway from WIZE to Wi-Fi, especially for indoor and industrial uses. And together with these products, you have in our website a lot of different kits, packs with different products. Some of them also including some specific sensors. And for instance, here you see in this slide the gathering park or the parking park. This comes with some specific sensors for these use cases, and you will find also in our wiki site the tutorials in the step-by-step process to create one solution in these ecosystems. Next, Greg. In terms of the programming of our devices, we have integrated the libraries into the Arduino ADI. You have the instructions how to adapt your Arduino ADI with our products, and also to platform.io for those ones that are more familiar to this other ADI. So with these ADIs, it's super simple to create code, debug, program, everything. Next, Greg. And we have also all this code is open source, so you can find it in our GitHub folder. There are a lot of different examples that you may run on the K1, K2, or the gateways. You can easily connect some sensors, especially those ones that you can find also in our website. And you can also create master-slave communication on one direction. You can implement an MQTT gateway and other features that you will find there, and that we are continuously updating for the moment by ourselves. So we expect also that the community start creating also some other solutions that we can share with all the community of users of our products. And I think that's all from my side. Just be open to any question you have regarding this. Thanks.
Okay, let's start the Q&A then. Let me just try and find some some questions. So there are some questions about whether 169 megahertz is allowed in specific countries, or if there's a big list of it. I can't answer that now, but I can try and find an answer to that later and pass that on to you people that are asking.
You can contact me, Eric Farnier speaking, at Suez, and I can help you on that. I have already covered a wide batch of countries.
There's a question here for AllWize. How AllWize K1 makes the payload available?
Well, so when you are using the library, you have an open payload that you can use on your own. I think we have some implementations in our GitHub to adapt to some specific formats typically used when you are sending data from sensors. I mean, it's a format where you can tag your data and then put the value of your data. But essentially, you have an open payload that you can adapt. In the example for MQTT that we have in our wiki site, you will see how we pack the data in in a specific MQTT format that you can easily get recovered in your platform at the end when you receive the data into the cloud. But there's no specific format that you have to use on the payload. You just have a specific amount of bytes. I don't remember exactly how many right now, but you have a specific amount of bytes that you can use on your own.
Okay, there was another question there about the data rates of Wize, and Wize has 3 data rates that Radiocrafts supports at least, which is 2.4 kilobits per second, 4.8 and 6.4 as well. Eric, do you want to take the question from Cassidy?
Yeah. Is Gateway implement server, or it can be just it's a router? I also have seen some questions about the firmware download impact on the battery down there. We have planned. We are building smart metering device since a little more than 10 years now, and what we plan is to have 5 firmware download over the lifetime of the device without impacting the battery itself. I want to add also that this firmware download has been widely tested today by GRDF for its rollouts, and that it is working fine.
The recommendation for an antenna that is based a lot on the application itself. If you would like further help with that, then you can contact support at Radiocrafts, and we can help you with your specific application. Typical applications are for the water and gas industry for their meters, and also industrial IoT, and some of the applications that AllWize also have kits for as well, which is the gardening pack and the parking sensors. Is that correct, Marc?
Yes, right. I would say that Wize in general, it's very good when you have, especially if we put in comparison with LoRa and Sigfox, that maybe it's the other protocols that people knows and it's trying to compare to. But Wize really makes a difference when there is a lot of infrastructure that can block the signal, and Wize can, due to the frequency it's using and the performance of the modulation, really works better than the others. This means, for instance, a city environment when you have a lot of buildings, that some of them may block the signal, or maybe when you want to communicate from outside to inside a building. Here is where Wize really makes a difference. All the applications surrounding these cases, I think are better to do them with Wize. For the rest, the power consumption is really good, and the distance it's also really good, equal or better than LoRa. And yeah, the capability of having also a bit more bandwidth also makes the power consumption, from our experience, makes the power consumption better, because when you want to send a packet, you need just less time. So the device can just switch on, send the data, and sleep again in a super short time.
Yeah, there's a question here for Eric, and it states, what are the steps to test or subscribe to the Suez offer?
The very first step is very easy. Contact myself, and I will help you through. Clearly, there is an agreement to be set up between the partner and Suez Smart Solution. If you intend to deal with us or with GRDF and AllWize, if you want to be dealing with their network. Alternative way is to contact the alliance itself.
There's a question here about LoRa and Sigfox. Well, the Wize has better data rates than LoRa and Sigfox, and it also has longer range and better penetration, as well as not being bound to any particular company to use. And I also believe that there is an electric general application layer, or certainly one in discussions.
I see two questions from down under that I can answer at once about what devices are deployed in Melbourne and New Zealand. I do not have the numbers right now. I know the pilots are starting since something like 1 year now. I would advise that you get in touch with our guys over there, Sean Cohen, maybe if you know him, or if you don't, then again, you just contact me at eric.farnier@suez.com, and then I will help you through. And the question about the frequency allowed in Australia or not, right now the frequency is not allowed, but we've been working out with the authorities since 2 years now. At the beginning, we were thinking of using a very close frequency that was, I think, 174. Today, we have been allowed to use the pilots, which are running well, and I think we already have an agreement in some areas that makes that we believe that we will be allowed to use the 169 MHz frequency in Australia and New Zealand. This shows that even in countries where initially it is not an open frequency, in the end, it is possible to use it.
There is a question from Zubair about using the WIZE protocol for not AMR applications. Zubair, that's mainly what we do in AllWize. So the kind of applications we do are quite far from metering. We are doing projects, pilots still, but projects in lighting, street lighting control. We are doing also waste. There is a company in France that is doing waste dumpsters, monitors. And we are also doing some things in waste, specifically waste dumpster lockers, and we are also doing other things in the water utility sector, but not in terms of automatic metering reading, but in terms of bulbs, sensors, and other infrastructure deployed for the water services. So the answer is yes. I mean, you can now do everything you want with the restrictions of the protocol, of course, but in terms of application, you are not restricted anymore to the metering.
And just to add to that, for Jimmy's question, you don't need to register anywhere to use the WIZE protocol unless you wanted to, for example, use Suez's network.
So one question regarding electricity. We have been dealing with electricity for some years now, for few hundreds of points in France, but the most important deployment that you have to consider is the fact that in Italy today, since 3-4 years now, it has been decided that all the smart meters for electricity will have a backup based on 169 MHz transmission, together with the CPL connection. And what we hear so far is that the radio connection is used in many cases. So yes, there are no limitation against electricity to use this technology. And I see again a question regarding the antenna and the wavelengths. Of course, the physics is here. The wavelength is what it is. But as Greg mentioned, we have been developing several devices together with Radiocrafts since those past 10 years. And clearly, when you consider a water meter or even a trash bin sensor, you do not have the room for a 1.7 meter long antenna, and we managed to have shorter antennas that works fine.
You can also find in our AllWize kits that we use really short antennas. They are coil-based antennas, and the performance is quite good. I mean, it's not here, once again, the physics are there, and the bigger the better. But when you have the dimensions constraints, you can find interesting antennas now for 169 that works really good.
I see a question here that says, is Suez planning to deploy a network in Portugal?
In fact, we are already using 169 in Portugal. We already have deployed water meters. I can't tell you exactly where, but I know there are some thousands of devices already connected.
In Coimbra, Eric.
Okay, thank you.
I see also a question about the meters manufacturers. You can go to the Wize Alliance website. You will find there all the current partners, and some of them are meters manufacturers. But maybe you, Eric, can shortlist some of them.
And then a question for Greg, I guess. When should I consider WIZE against wireless M-Bus?
Well, I would choose WIZE specifically when you need a longer range or you need more penetration power, whereas M-Bus is very good because it's a very well-established system. WIZE is well-established too, but it hasn't been around for the 10 years that wireless M-Bus has been. Yeah.
I understand here you speak about 868 when you speak about, I think, wireless M-Bus. Remember that wireless M-Bus standard is today also including the 169 MHz frequency. The thing which makes a big difference with WIZE is that everything is specified inside WIZE. Down to the firmware download and things like that, and the way you will connect the device to the network. Where wireless M-Bus is more a toolbox. Okay, so if the question is against 169 wireless M-Bus, then you get my answer. The thing is that WIZE will give you something much more complete to connect your device, where when you are using 169 megahertz with wireless M-Bus, then you have to define and design behavior of all your network. And find people implementing it also.
Eric, do you want to also take the question from Dennis about public networks?
Are there? Oh, well, okay, what can I mention to you, Dennis? In France, we have Bordeaux, who has already a partly private network. We also have, since the almost the origins, 2010, we have a network that is deployed in Malta, that belongs to the authorities. What can I think about otherwise? We had some example in France with the military. Of course, this is not publicly open. Well, I would say mostly technically it is feasible. There are not so many deployed today. I hope there will be one tomorrow in Singapore and in places like that, because we're working on that.
We have also here in Spain, we have the Chingudi area, which is in the Basque country. It's kind of a big area. It's not just a single city, but it's an area with some different towns and cities. And the network it's 100% public, and they use it either for the water metering, but are also starting to deploy other systems with the WIZE connectivity now that it's something open. So they are really seeing it as a smart city infrastructure, and this is something that I'm already talking with some other municipalities that I can't disclose. But it's something that cities are start to take in mind when they are considering on build LPWA infrastructure for the city, for the sensors, sometimes also for the citizens. They are also thinking now considering WIZE as an alternative, apart from LoRa, that maybe was the only option a few months ago.
Okay, I see a question from Armando. What kind of tools are available to evaluate the network quality? The way we do that is because we have inside our IT suite, there is a supervision tool, of course, that is constantly checking the coverage quality. So that is a way to do this quality control. Next question from Suez. Link WIZE Gateway and information about it. Again, to go more in detail, you can either contact the Alliance or myself if you want. And again, maybe I don't know if you need to write down my email address somewhere.
Okay, is that it for all the questions?
Oh no, you have my email address here.
Okay, thank you very much for everyone's attention. And if you need more details, you can always go to any of these websites to find out more.
Thank you, everybody. Have a good day.
Thank you. Keep safe. Bye-bye.
Bye, everyone.